All right. Good morning. Okay. Now people are rolling in here. That's great. All right. I had some, I was going back and forth, back and forth. What do I do? What do I do? We didn't finish chapter 5, obviously, which was supposed to be on the test. And then, so what I've decided to do is we're going to keep the test. The test is still on Thursday, but it's going to be on less material. In fact, what I want to do is I want to train you to do the questions on the test, and then we'll come back and we'll fill in other types of questions next week. Okay, so today I've put together a practice test that I want to go through with you guys so that you have full solutions, right? Full written out solutions, so you know how much work you need to show, right? But also how do you go through and do these problems. And then if you're working through practice problems, because I know you are, you guys are such a good group, and you work through extra problems and you try to tackle these big hard problems, but if it's not a question that feels very similar to what's on that practice test that I posted, put it off until next week. Okay, so for the test, I want you to, so we have test number 2 on Thursday. Okay, and for the test, I only want you to focus on those types of questions. I'm not trying to lead you astray. I'm trying to make it all come together and make it as easy as possible for you, because I know it's kind of a tricky situation this Thursday. So it's on Thursday, March 18th. That's the pickle. So for the test, I only want you to focus, want you to focus on questions that are similar to, if not exactly like, so on questions similar to those on the practice test that we will go through today. And there are a couple of questions that you'll find when we go through them. It's like, hey, so we're supposed to do this on a test on Thursday? Yes, but only that, right? No thinking outside the bun here. The story is going to change, right? So I don't know, James buys this car and he has to repay the debt, or maybe Sally buys a house, right? So the story is going to change, but the idea is going to stay the same. And then of course the numbers will change, but again, the idea of each question is going to be exactly the same. I mentioned last test that I didn't have the heart to break it up into multiple parts and give you kind of timed parts, but we do have to do that for this test. I don't love that idea, but it is something that we have to do. So okay, we're going to do that. So the test is going to be broken up into 4 parts, and each part, I'd appreciate it if you didn't share it with other sections, but because you're supposed to only have 15 minutes per part, but I felt like that was a little bit too tight, so I'm making it 20. Okay, so just don't go sharing that. Well, it's on YouTube, I guess, but no one's gonna listen this far. Right, so each section you're gonna have 20 minutes to do. It should be 15, but we'll do 20. And you have to do the first part before you move on to the second part, and so on. Yeah, more time is always better. So right, so it's going to be a little bit weird, and I am running into some programming issues, but I'll have a Moodle practice test available for you as well, just so you can kind of get an idea. Okay, so the test will have 4 parts, and what you'll see on this practice test, okay, notice that I've broken it up into part 1, part 2. What I did was I took the actual test, and then I reworded it, I changed some numbers, but these are the parts. Okay, so just kind of for the rest of the week, just kind of focus in, or until Thursday, just focus in and study these questions. Okay. So we'll go through them, right? But there's 4 parts, and the first 2 parts are going to be with simple interest, and then the last 2 parts are going to be with compound interest. So the test will have 4 parts, and part 1 and 2 are with simple interest, right? So that tells us where on the formula sheet we're working, right? And it eliminates the need. So what I'm telling you now is you don't really need to think about, okay, is it a simple interest problem or a compound interest problem, which we typically would have to do. And then parts 3 and 4 are compound interest problems. Okay. So, all right. Any questions before we start working through these problems? So I will go a little bit quicker through the simple interest problems, because I do want to slow it down, because we haven't spent a ton of time with compound interest. The problems don't really change. We just have that added step of finding the periodic interest rate I and the number of compoundings n before we can do any calculations. But other than that, the questions don't actually change, right, from simple interest to compound interest. So so the check option is good when it works, but it's really disheartening when it doesn't work, right? And so when it's marking something wrong that's actually right, I don't actually like that. So for the test, you will not have the check option, but the only reason that is I want you to just trust your gut, and because sometimes it does weird things, like if all the answers aren't filled in, it'll mark it wrong when it's actually right. And so I don't like that. If you're okay with having the check option, but it might mark it wrong when it's right, I don't know, it just feels like it might be misleading and really disheartening. So I would rather, because I'm checking all your work, right? So I will be adjusting your grades based off of your work, just like for test 1. So what I would rather do is show all your work nicely, and then I can go in and adjust your grades anyways. So I'm not going to have the check option there. I've committed, no check option, but it's because it can be really upsetting. So yeah, I know it's confusing, but check option, of course, for assignments, and I'll have it for the practice test too. Okay, so all right, let's get to it. Practice test. I posted this on Moodle, and part 1, question 1. Just going to bring this in here. Maybe delete some dead space up there. There. Okay. So the structure is going to be question 1 is kind of a quick and easy question, and then question 2 is going to be a bigger question, right? And so question 1 is worth 1 mark, and question 2 is going to be worth 3 marks. Sometimes, like here, I might, because there's 2 different answers, I might make it 2 marks just to boost your grades a little bit, hopefully, right? And so maybe I should write that here. Question 1 is kind of a short answer question for 1 mark. And question 2 is kind of a long answer for 3 marks. And maybe I'll start this on a fresh page. How about, so you don't need to have all my random blurbs if you're looking at it later. Okay, so you will need to have a timeline for question 2. Okay, so question 2, need to show timeline for all the question 2s, and for question 1s, timeline is not necessary. How do you spell necessary? There, let's commit it. 1 C, 2 S's. Oh. Right, so you can do a timeline because it might make it easier if you find it easier to visualize, but it's only for question 2 that you need to show your timeline, and that's what you'll see in the work that we do. All right, so no worries. Okay, so let's get to it. So like I said, oh yeah, so do you mean this practice test? Yeah, we're gonna go through them all together today. So then you'll have the solutions. Yeah, with all the work worked out too, which is nice. All right, so on January 9th, Jimothy borrows $13,000 at 3.8% to set up a tiger sanctuary and agrees to repay the loan in 246 days using simple interest. Okay. There will be some extra information that we don't actually need. And so in this case, we don't actually need the January 9th. And it might send you down a rabbit hole, the days between dates, okay? But so we don't need it, but it's there, right? And so here I'll say not needed in this case, right? Because we want to find the amount of interest paid on the loan, right? And the maturity, which is also called the future value of the loan. And of course, this is simple interest, but you can just kind of turn that part of your brain off and say, okay, part 1 and 2 are simple interest, part 3 and 4 are compound interest, right? So let's see here. I have a principal amount of 13,000. I have a rate of 0.038. And the time that we're going to take to repay this loan is going to be 246 days. Now, time is always in years, right? So I have to divide by 365. So 246 over 365. Okay. So then for A, the amount of interest is capital I, And in this case, because I have PRT, that's the easiest way to find I, right? And so that's what I'm going to use, right? So I equals PRT. Now I can just plug in all my values and I get 13,000 times 0.038 times 246 over 365. Okay. Now I can do this, and I'm actually going to grab my my calculator on the side here, because flipping back and forth, it gets a little laggy. So until we need to show our workout, or you need to see what I'm doing, then just do it on the side here. So because I'm multiplying and dividing, I can just do it in any order, but I'm going to start with 246 over 365 times 0.038 times 13,000. So the amount of interest paid, and I would recommend, because I'm checking your work to adjust your marks, a surefire, in case you've rounded incorrectly, right? So something happened, what you should do is you should write out all your decimal places, because then I can at least give you maybe a couple more, or these aren't worth very much, right? But a little more marks than if you just show the rounded answer incorrectly, right? Because then I don't know where you got that from, right? So for me, I write out the full answer and then the rounded answer. And I suggest you do the same. 332.9424658. That's what I get. Which then I round it to money, 332.94. So that's the amount of interest paid on the loan. So now part B asks, what's the maturity or the future value of the loan? So now we need to remember that, okay, well, the future value is going to be the principal amount plus interest, right? And so part B says that the future value is the principal amount plus the amount of interest. I have P and now I have I. I can easily put these together, and I'm going to find that I'm at 13,000 plus 332.94. Both of those are, of course, in money already, so I can just go ahead and add them up. And I get 13,332.94. Right. So it's been a while since we did those, but hopefully they feel pretty comfortable. Right. I'm keeping an eye on the chat in case you have any questions. So if anything comes up, then throw it in the chat or turn your microphone on, but usually it startles me. Someone's here. So let's go on to question 2. Remember, question 2 is going to be a bit more work, right? So this is a long answer question. Dennis takes a simple interest, and okay, so kind of a word of caution here. This was a type of question that we were told should be on test 2. So, okay, I'm just following the rules here. It's going to be weird. It's not something that we've really seen before. It uses all the things that we've learned already, but we haven't seen a question exactly like this. So I just want to show you how it's done, and then but then you'll see, okay, I know how to do that. Okay, it's just a weirded, wordly question. Worded weirdly question. It's been a long day already. So Dennis takes a simple interest 147-day note, which from what I understand, it's basically like an IOU, where it's like, okay, I'm going to pay you back this amount with this amount of interest. And it could be in a specified amount of time, like it is here in 147 days. Okay. And so from what I understand, that's a note. That's not necessarily correct. I'm not a business teacher, but I do know the math. So here we go. So Dennis takes a simple interest 147-day note from a client with a face value, so a value today, of $14,000 and a rate of 5%. So this client says, yeah, I'll give you this $14,000 note. I know I owe you money. I don't have it right now. I'll pay it back in 147 days at a rate of 5%. You say, yeah, sure. But then after 56 days, Dennis gets impatient and he goes to the bank and says, oh, I've got this basically IOU, right? Making me think of Dumb and Dumber, right? I've got this darn note. Can you just buy it from me? And I'll give you a discount rate of 9%. Okay. So what this is going to look, what this timeline is going to look like is like this. And of course, because it's a long answer question, we have to have a timeline. So before we even go ahead and read those questions, well, actually, let's do it. We want to find the maturity value of the note. So after 147 days, how much is $14,000 worth at a rate of 5%? We can do that. Right? So that's the maturity value of the note. And then how much did Dennis sell the note for to the bank, right? So at 56 days, how much did he sell the note for? And then how much interest did the bank get from this transaction, right? All right, so we are here today. We've gathered here today. And then I know I've got cutoff points at 56 days and 147 days. So I'm going to put 56 days here and 147 days here. Right? Remember, put your dates up top, dollar amounts below. Okay, so I know the value today is 14,000. So I'm going to put that dollar amount down here, 14,000. And then what happens is, okay, that is going to grow, right? He has to pay, or he gets 5% interest, right? So here the rate is 0.05 and the time for this, so remember the time is the length of the arrow is 147 days. So 147 days out of 365. And that's going to be the future value of this thing. And that's going to be my first thing I calculate. So then I use the little subscript 1 just to remind myself that, okay, this is the first thing I'm calculating, then the second thing, etc. Okay, so what we've captured here is the 147-day note. It has a value of 14,000 today, and the rate is 5%. And so this 14,000 is going to grow to some future value 1. But then he gets impatient and he says, you know what? I'm just going to cash out. And I'm going to sell it to the bank at a discount rate. So a discount rate of 9%, right? So he would be getting 5% if he just stuck it out. But now he's saying, I'm going to basically put this thing on sale for 9% off. So now I'm going to say the rate for this arrow is 0.09. And remember, the time for this arrow is the distance of the arrow, which in this case is 147 minus 56, right? And so 147 minus 56 is 91. So T is 91 out of 365, right? Because it's all in days. And because I'm pulling this arrow backwards, that puts me at a P2, which is how much why wouldn't it be from today? Because what he's actually selling is this value, this future value. But then he's saying, oh, I'm going to discount that amount to you when he sells it to the bank. And so that's why it's going from the 147 days to the 56 days. Mm-hmm. So, so what's going on here is there are 3 parties involved, right? So Dennis takes fake money, an IOU from a client. The client is still going to pay at the 147-day mark. So the client is still going to pay this future value 1. But then Dennis says, you know what? I don't want to wait that long. I'm going to sell this thing to the bank. The bank says, sure, why not? In 91 days, we'll get our money, right? And so kind of a weird situation, but there's actually not a lot of calculations in here, so it's kind of nice. Okay, so this is, okay, I want to put maybe here. The maturity value of the note in this case is future value 1, and the amount that Dennis received for the note is P2. Now let's just think about the amount of interest received by the bank, right? Well, the amount of interest is the future value minus the present value, right? The difference between those two is all interest. And so, well, that's going to be future value 1 minus P2, right? That's the amount of interest that they've gotten, right? Because they picked it up for this P2 amount, and then they knew they were going to get future value 1 in return. So now it's just a matter of doing these calculations, right? And so future value 1, which is where we have to start, right? Because we need to know the future value at 147 days before we can find the amount that he sells it to the bank for. So future value 1 is P times 1 plus R times T. Remember, this is simple interest, so make sure you're in the simple interest section of your formula sheet. So then this is going to be 14,000 times 1 plus 0.05 times 147 over 365. Remember that they have different rates, right? So he would be getting 5%, but then he says, I'll just mark it down to 9% off, right? And so let's do this. Start 0.05 times 147 over 365, then add it to 1, then multiply it by 14,000. But so you have an idea of how much work I need to see, I'm going to just skip straight to it maybe. Or I could use a different color, I guess, but need a legend. Let's just go for it. 147 over 365 times 0.05, oops, 0.05 there. I should redo it, my butterfingers. 147 over 365 times 0.05 plus 1 times 14,000. You should be able to do it all in one go on your, well, like kind of build it up in your calculator. I get a future value of 14,281, 91781. Again, writing out all the decimals before I go ahead and round. So now I have 14,281.92. Hopefully that's what you guys found as well. Otherwise I slipped somewhere along the way, but feels pretty good, right? It's larger than 14,000. It's like a step in the right direction. Okay, so this client, Dennis's client, has committed to paying 14,281.92 in 147 days. Right? Okay, so then That is the maturity value of the note. I guess I should say A. Done. B, the amount Dennis received for the note. So now I'm trying to find P2, which is the future value over 1 plus R times T. If I just rearrange and solve for the principal amount, later we call it PV for compound interest, right? Now, the future value is this 14,281.92. So 14,281.92 divided by 1 plus, and remember that rate has changed to 0.09, and the time is 91 over 365. Okay, 91 over 365 times 0.09 plus 1, and then 14,281.92 divided by that puts me at 13,968.49005, which in money, 13,968.49. So then the amount of interest that the bank gets, right, is the future value, right, minus this present value or this principal amount. So C, the amount of interest is the future value minus the principal amount. So they make, whoops, 14,281, I think it was 92, yeah, minus 13,968.49. Dennis must have been in the pinch, right? He was owed 14,000 today, and then he got impatient and decided to take 13,968 instead. Who knows? So subtracting those two, 14,281.92 minus 13,968.49 puts me at $313.43, and it's to 2 decimal places because it's already rounded. So that is the answer. Good. So kind of gonna keep the ball rolling here, and let's go ahead and start part 2. So that's part 1. Okay. I talk around it a lot, right? When you sit down and you do part 1, right, then you only have 20 minutes to do it. So just keep that in mind, right? I talk around it a lot, but you will need to keep your pace up, right? So I don't like adding that stress, but it's there. It's there. All right, so part 2. So then when you're finished with part 1, part 2 will open up, and now you're back to kind of an easy question, right? And so part 2, question 1. Find the initial amount invested. So find P, right? If after 743 days, the maturity value, which is the future value, right, is 23,000, and the rate of the return is 5% simple interest. So again, confirmed, we have a simple interest problem. So we're just going to go ahead and use it. In fact, what you can do, I like to list all the stuff that I've been given, but what you can do is you can just set up your equation and fill it in, because this is such a tiny, tiny problem, right? And so we know that the future value is P times 1 plus R times T. So we have the maturity value is 23,000 which is P, which is what I'm trying to solve for, times 1 plus R is 0.05 and T is 743 over 365, right, in days. We can solve for P, right? P becomes 23,000 divided by, I'll simplify this, 743 divided by 365 times 0.05 plus 1. So remember, you have to keep all your decimal places, right? So even though I'm only going to write out as many as I have on the screen, it keeps going, right? So divided by 1.101780822 keeps going and going, right? So I'll do ... Whether you like to store it or use the 1 over x and then multiply it by 23,000, or there's also a previous answer button. So however you want to solve it, you should end up at the same place, which is 20,875.29529, which in money is 20,875.30. Easy, right? Question 1, quick one, Mark. All right. How about question 2? Merlin has agreed to buy a car for $27,000. He signed a deal to repay the debt with 3 payments. Okay, so we've got 3 payments, 1 in 5 months, and a payment of the same size. So of course, because we're not given the payments, we'll have to solve for them. And this we did do in class, right? So feeling good. So a payment of the same size in 11 months, and the final payment, which is twice as large as either of the previous payments because they're the same, in 1.5 years. If the rate of interest is 6% simple interest, so again, confirmed we have a simple interest problem, how large are each of the 3 payments? So the first and the second payments are the same, right? And then our third payment is twice as large as one of those. And then it also says, use 1.5 years from today as the focal date. So what you're going to do is, what that says is pull all your arrows to the 1.5 year mark, right? And so when I give you the focal date, it's meant to make the question easier, right? By saying, okay, do your work, pull all your arrows to the 1.5 year mark. Okay, so we need a timeline, right? It's a question 2, so I need a timeline because it's a long answer question. And of course, I don't know how you would tackle this without a timeline, to be honest. Okay. So we'll start here today. This is when he agreed to buy a car, and then we've got ticks at the 5-month mark, the 11th month, 11-month mark, and then the 1.5 year mark. Okay, so 5 months, 11 months, and 1.5 years. Okay. Remember how we deal with these unknown payment amounts? We just use X, right? So X is going to be a placeholder for the amounts that I'm paying at each of these points. So the first amount at 5 months is the same as the amount at 11 months, right? So I just use a little X as a placeholder, and then all I know is that the third payment is twice as large as the other 2, so that's going to be 2X. what Merlin has agreed to pay is 29,000, right? Or sorry, 27,000. Seeing nines everywhere. 27,000, right? And he needs to pay it off with these 3 payments. And so here, this is the focal date, right? The 1.5 year mark, meaning pull all your arrows to that point, okay? So what happens, and remember, I like to kind of move from my focal date, and then I like to pull whatever arrows are the closest first, just to make it a little bit cleaner. And so this X is going to become some future value 1, right? That X is worth some amount in 1.5 years from today. This first X is also worth some future value, right? And the only reason I'm pulling these, I know to pull these, I'm kind of on autopilot because I was told to pull them and make them all work out at the 1.5 year mark, right? So when I give you the focal date, it just makes it a lot easier. So now what I need is I need the sum of all these payments to equal the future value of 27,000. So here we have 27,000, which is also worth some amount, so some future value 3 at the 1.5 year mark. But the key here is that when you add up, and remember you're adding 2x with future value 1 and future value 2, it has to equal future value 3. So just highlight here, right, that all of these are being added up. Don't forget that 2x there. So each arrow, we need to put the time on each of the arrows, and a little bit tricky, right, figuring out the time between 11 months and 1.5 years. But I can convert 1.5 years into months, right, which would be 12 plus 6, 18 months. And then the distance between 11 and 18 is what, 7 months, right? And so, and I guess that it checks out, right? So here, my time is going to be 7/12. Making sure that you really focus and keep the appropriate time on the right arrow. Stuff. Between 5 months and 18 months, right? So here, maybe I'll make a little note that this is actually 18 months, right? 1.5 times 12, I'm just making sure it is 18. So then here, the time between 5 and 18 should be 13 months. Just confirming, yes, it is 13/12. There's nothing that says we have to use 18 for this 27,000 arrow. We can just use 1.5 because we have it. So T here is 1.5. And the rate, I'm just going to jot it down because it's the same for all of these. I'm going to jot it down. And it's 0.06. Okay. So now I'm going to go ahead and do these calculations, and we can do these calculations with the x's, right? That's not a problem. And in fact, we've done it before, right? So let's go ahead and find all 3 of these future values. And just so we're not scrolling so much, I'm going to try to line them up side by side, but it might be tricky. Future value 1 is, and maybe I should just, I'm going to jot down the general formula over here. The future value is P times 1 plus R times T because we have simple interest. So then the future value 1, The P for future value 1 is X. That's okay. We're going to get X times something, and then we're going to add up those X's and then solve for X. So we've got X times 1 plus 0.06 times 7 over 12. Not bad, right? So then I get 7 over, I always turn off for some reason they put the on off button where usually the clear button is. It's very confusing. 7 over 12 times 0.06 plus 1. This makes 1.035 times X. Notice that now you have 2X plus 1.035X and then plus something times X. So we're going to be able to solve for X as long as we have a value down here. So then future value 2 is going to be also X, right? Future value 2 has a principal amount of X, and then times 1 plus 0.06 times T for that one is 13 over 12. Making sure you don't confuse the arrows here, right? So 13 over 12 times 0.06 plus 1, is going to be 1.065 times X. Right? I just move the coefficient out front. So then finally I can find future value 3, right? And so future value 3 is, well, now I have an amount here, 27,000. So 27,000 times 1 plus 0.06 times, and then the time is already in years. Yeah, that's great, 1.5. So 1.5 times 0.06 plus 1 times 27,000 puts me at 29,430 even. Hey, that's great. If it wasn't, I would round here, right? I would round to a dollar amount. But here, because it's nice and even. So what we say is, well, we know that 2x plus future value 1 plus future value 2 have to add to future value 3. So we know future value 3, Merlin, right? Merlin's buying a car. So Merlin has committed to paying 29,000. Oh, sorry, it's jumping around here. Committed to paying $29,430 1.5 years from now. Okay, so these payments have to add up to that same amount. Otherwise, we've done it wrong. Right, so we know that the future value 3 must be equal to 2x plus future value 1 plus future value 2 from the timeline, right? So now I have values for all of these. 29,430 is 2x plus 1.035x plus 1.065x. Now, it just happened that all these multiples worked out to nice numbers. If they didn't, you would have to store them, right? But I think you've worked enough with these to know to keep all your decimal places. So now, if I pull out a common x, right? Because I'm trying to solve for x. X is the unknown, the first and second unknown payment amounts. Right, so what I have is 29,430 is x times 2 plus 1.035 plus 1.065. So I can do 2 plus 1.035 plus 1.065 is 4.1 times x, so 29,430. So then x is 29,430 divided by 4.1. 7178.04878. if we round that to money, right, then our first payment is that $7,178.05. Second payment is the same, and then the third payment we established was 2 times that, right? And so we were asked to find each of the 3 payments. So here we are. The first payment is $7,178.05. Second is $7,178.05, right? Because we were told they're the same. And then the third payment is times 2. So 7,178.05 times 2 is 14,356.10. And I'll just clarify here that this is 2x is 2 times 7,178.05. But you can just go do it. Good. Okay. So again, I do a lot of blabbing around these, right? But if you just kind of sit down and go for it, you'll want to keep your pace up. But this just gives you an idea of, and all of this work, right? I haven't shown any extra work. So if you're showing less work than this, that's not enough, right? You need to show all the work that I've shown here, including the timeline, right? Okay. Hopefully you guys are okay with if we just keep going. I'm worried. I really want to work through all of these problems. Let's just do it. This is for your test. So if you need a break, then go make yourself a break. But we forge ahead today. So part 3, remembering that part 3 is where we start compound interest, right? So we need to kind of keep our wits about us because we haven't done a lot of compound interest problems, right? We did some, but and then I'm kind of saying that we did 5.4 today by way of these problems that we're going to do, but we'll go back over it next week. But like I said, just focus on these problems that I'm giving you today. Okay? The short answers you've got in the bag, right? Okay, so this is where now compound interest, right? So just make a note. Parts 3 and 4 are using compound interest. Setting up the problem is the same though. At what weekly compounded rate of interest? Okay, so now my compounding frequency is weekly, right? And I'm trying to find R. But we said last day that in order to find R, or maybe it was the day before, I need to first find I, right? And so will 19,000 increase to $34,170 over a term of 7 years, okay? And so now what I have is, and you don't need to write out what you were given, but I do find that it's helpful. So we're given first that F is 12, right? Weekly. That's weekly, that's monthly. Well, would have been a disaster. 52 weeks in a year. Yes, I'm convinced. Okay. And we have a present value of 19,000 and a future value of 34,170, and the time is 7 years, which is nice because it's already in years. And I want to find R, but first need to find I. and then I equals R over F. So that's how we're going to find R. Right, so a little bit more work, but in part 1, the short answer, you're going to have to find R, and in part 3, you have to find R, and in part 4, the short answer, you have to find T. So we worked through those, so that's why I feel comfortable. Okay, so if you wanted to, you could skip straight to the formula. The future value is the present value times 1 plus I to the power of n, right? Or because you know to find I, right, from your formula sheet, right, on your formula sheet, now where is it? You have I. Right, you have the formula for I, so you can just go ahead and use it. Right. So you can use this and solve for I, or use this from the formula sheet. Just so we don't have to go ahead and solve for I. And because it's on your formula sheet, I'm just going to use I equals the nth root of the future value. I need to turn that up a little bit. Over the present value and then minus 1. So in this case, right, I need to find n, right? I don't have n yet, but I can add it up here, right? So n is the time times the frequency. Number of compoundings is n. And so in this case, it's going to be 7 years times 52 weekly compoundings, 364. So I'm going to see 364 compoundings. So what I have here is I is going to be the 364th root of 34170 over, I think it was 19,000, and then minus 1. Yeah. To take the 364th root, right, I need to raise everything under the root to the power of 1 over 364, right? So this becomes 34170 over 19,000 to the power of 1 over 364 and then minus 1. But once I have that, I just plug it into my calculator, right? So I do what's inside the brackets first, 34170 divided by 19,000 to the power of, and because I want to keep that 1 over 364 together up in the power, I'm going to put brackets around there. So bracket 1 divided by 364 equals, and then minus 1, make sure you minus 1. Don't want to forget about that. So I end up at 0.001613688. So now, right, I equals R over F. So then 0.001613688 is what I just found. Let's get this over so it is lined up, is R over 52. And I'm going to keep it on the same page. So I scoot it up again. Scooting. So then R is whatever is on your calculator, right? For I, you need to multiply it by 52 to solve for R. So times 52 puts you at an R of 0.0839 11786, or 8.39%. In general, for dollar amounts, you should be rounding to 2 decimal places. For these rates, when you're putting your answer into Moodle, you should have at least 2 decimal places for the rates. Right, it'll accept 2 decimal places if it's rounded properly, but you're safe to keep going if you wanted to add more decimal places. Good. It looked like a bad problem, but it's actually, it's not that bad, right? You just have that added step of after you find I, you have to find R. So I thought I was pretty funny here. It's hard to change the story. Well, I don't know, I'm not very creative, but here's my masterpiece for this practice test. The manager of Dunder Mufflins. No, Dunder Mufflers. I screwed it up. Dunder Mifflin. That's what it is, right? Now it's all a bog. Anyways, the manager of Dunder Mufflers has hired an accountant who suggests opening a savings account for a rainy day. So there's some more kind of information that we don't really need, but just some backstory. Changing the question, not really. You can just ignore that first sentence. She opened a savings account at 6.1% interest compounded bi-weekly. So right away, make a note to yourself, okay, your frequency is going to be 26, right? So you're going to need to have those compounding frequencies available somewhere so that they're easy to grab. With a deposit of $7,000, let's call it, on December 4th, 2012. Looks like we have to use the days between dates. We do. We can do it. We know how to do it. On January 19th, 2013, so from December to January, she deposited $1,700, let's say. Then on April 21st, 2013, she deposited a tax refund check for, doesn't matter where the money came from, but she deposited $2,900 some odd dollars. Find the value of the first deposit, so this $7,000 from December 4th, on April 30th, which happens to be my birthday, 2013. I want you to make sure that you look and, right, April 21st is not the same as April 30th. So this is an additional time point that we're adding, and that's going to be the case on the test too, right? So exactly same layout. Right, so you just want to check to see, okay, this is an additional time point that I have. And then it looks like we just want to find the value of each of these deposits on April 30th, but then of course also the total value on April 30th. Can do, right? Here, really the only hard part is finding those days between dates. Yuck, right? So here we go. Okay. I'll just go for it with the timeline. So we've got a deposit. So the initial deposit is on December 4th, 2012. Then we've got, and I'll just put the dollar amount here, 7492. Then we've got a deposit on January 19th, 2013. And the deposit was 1764. Then on April 21st, April 21st, 2013 of the same year, we deposit 2,985, and then here we are at April 30th, 2013. And that's the day that we're interested in. Okay. So, all right, here we go. I'm wondering, well, I have the right to do whatever I want. I changed the compounding to biweekly, but to make it a little bit easier, and I don't mean, nope, let's just go ahead and use biweekly. It's going to be a little bit messier than it will be on the test, but here we go. So what we want to know is we want to know the value of the first deposit, but because I like to draw my arrows moving from the closest one into the value that I'm interested in, right? Because here I want to know the values on April 30th, making this my focal date, right? Making that the date that I'm interested in. Now, because I'm calling it the first, the second, and the third deposits, I'm actually going to call this future value 3. It doesn't matter. I'm just using these subscripts to keep them separate, right? Because that's my third deposit. That's the only reason. Then I've got future value 2, second deposit, and future value 1. That's my first deposit. And then if I add those all up, that would be the total. Okay. Now, I need to find the time for each of these arrows. So I need to use the days between dates, noticing that the end date here is always April 30th, 2013. So it takes longer for me to write it out. And you don't need to show your work. It's just if you want to kind of get part marks if you think you did it wrong or something like that. But so let's call this T3, T2, and T1. So T1, and maybe I'll do it, that's what I'll do. I'll do it in kind of a lighter green. So optional work, right? So you don't need to show this work, but it's just so you know where I'm getting stuff from. So T1 is going to be, okay, date 1, date 2, right? Remember doing these, and the days between dates is what I'm calculating. Date 1, remembering that we have month, dot, day, year. Maybe have that close by somewhere. Date 1 is, month is 12/04/12. Date 2 will always be for these 04/30/13. Let's go ahead and calculate that. So in our days between dates calculator, second date, date 1 was 12/04/12, enter, right? Because we have to save it. Date 2 is going to be 04/30/13, enter. Days between dates, compute. Where's the star? Okay. Are you guys getting 147 as well? Hopefully. Makes sense. 147, I'm sold. So the days between dates are 147. So here, this is 147 over 365. But remember, for compound interest problems, I actually want n on the arrow, and n is the time times the frequency. which is going to be 147 over 365 times the frequency, oops, for biweekly is 26. You don't need to have that anywhere, but you do need to know it. So you have 147 over 365 times 26, 10.47123288. Now here's where it got not as nice as on the actual test, because I wasn't thinking about it when I just changed the dates, that it would have to work out. On the test, it'll work out to whole numbers of n, which is really nice. If I had the frequency to be daily, then we would be fine, right? So that's why I was tempted. But what I will say is, if you're faced with this, right, which you won't be on this test, but it can happen later on, we aren't going to round these. Technically, we would have to round these, but Moodle can't be programmed, or it's not easy to program that in Moodle, so it hasn't been done. So as far as getting the right answer goes, we're not going to round these, right? So here, maybe store this in 1. Okay. That part is harder than I meant for it to be, and sorry about that. Okay, moving on. T2, date 1 is January 19th, so 01/19/13. Date 2 doesn't change, 04.30/13, and the days between dates is it wants me to do everything. Thanks. Okay. Should have stayed in the dates. So my date 1 is changing to 01.19/13. Enter. Date 2 stays the same. And then days between dates compute is now 101. So 101. Oops. So T2 is 101 over 365. Let's just go ahead and do T3 while we're at it. So it's going to be from 04.21/13 to 04.30/13. Running out of room here. Days between dates is, let's go back up. Change date 1 is all you need to do, and then you go back and you compute the days between dates. So 04.21/13, enter. Compute 9 days, which you could have calculated, right? But here it's confirmed, so that's great. 9. So here I get T3 is going to be 9 over 365. So on the arrow, I also need n is the time, which on future value 2 is 101 divided by 365 times 26. So 7.194520548. I'm going to store this in 2. Okay. And I'm just storing them here, but it's the same calculator, right? So, and then finally for that last n, I get 9 divided by 365 times 26. I have 0.64109589, which I'm going to store in 3. I also need, the last thing I need is I, right? I need I equals R over F, which in this case is going to be 0.061 divided by 26. 0.061 over 26. Let's see, 0.061 divided by 26 is some big kind of nasty number, which of course we're going to store as well. Lots of storing, right? Which is 0.002346154. And I am going to store this in 0. Why not? Good. All right. So here's my complete timeline. I can pretty much tell you what grade you're going to get based on your timeline, right? Did you map everything out correctly? Did you have the right idea here? Did you do all the math correctly? I can see that from your timeline. Now, let's go ahead and find these future values, right? Because that's what we were told to do. So let's start maybe from the bottom, future value 1, 2, 3, and then we can find the total. So future value 1 is PV times 1 plus I to the power of n, which in this case is going to be 7492 times 1 plus, and here's where things get weird. I'm just going to write store 0, right? Just to emphasize that I need all these numbers. So store 0 to the power of n, which in this case is stored in 1. So it's going to look a little bit weird. You're welcome to write in all the numbers if you want to, but you don't have to. You can just do what I'm doing here. Because now if I go 1 plus recall 0 to the power of recall 1 times 7492, I get 7,678.115456, which of course in money is 767812. Now I do the same thing with the other two future values. I'm going to try to squeeze them in here side by side, maybe make a little bit more room. Is the PV times 1 plus I to the power of n, which in this case is going to be 1764. You really want to make sure that you're grabbing the right present value for each of the calculations, right? You don't want to mess that up. Times 1 plus store 0 to the power of store 2. Okay. So here we go. Recall 0 plus 1 to the power of recall 2 times 1764 is 1793.992602. Money 1793.99. Do you think I can squeeze in? Keep bumping it over, bumping it over. I'm gonna do it. Mostly in case you wanna print this off and have it handy for the test, that you can do that, right? You're allowed to do that. In fact, I might even encourage it, I don't know, if you find it helpful. Because you do need to show all your work, right, and submit all your work. So I just am trying to keep it nice and tight. So here the future value is PV times 1 plus I to the power of n, which in this case, the PV was 2985 times 1 plus store 0 to the power of store 3. All tight. 1 plus recall 0 to the power of recall 3 times 2985. It makes sense that it didn't grow very much. It only got to sit there for 9 days, right? So 2,989.487879, which in money is 29.89.49. So then the total is future value 1 plus future value 2 plus future value 3, which is going to be, let me just do it here, 7, 6, 7, 8, 12 plus 1, 7, 9, 3, 99 plus 2, 9, 8, 9.49, only because I'm dealing with a page break here. A total of 12,461.60. 2 decimal places for monies. Okay. Good. Whew. All right, we're doing it. We're doing it. So that's the, I'd say the hard part here is finding the days between dates, because that's been a while, right? But then once you have that, all you're doing is finding future values 3 times over, adding them up, and then you're done, right? And like I said, your ends on the test will work out much nicer than these ones, okay? So you don't have to worry about that. All right. Part 4, let's do it. How long? And I'm going to get you to give the compounding periods and the years. Okay. So how long will it take for $4,000 to increase to $8,056, or sorry, $8,056? If you're able to earn 4% compounded monthly. So here, just make a note to yourself that here F is 12, right? So this is a short answer, so you don't need a timeline or anything. In fact, because you want to know how long, it means that you have to solve for n, then solve for t. So here, first solve for n, then find t, right? And then, so from your formula sheet, I'm just going to go ahead and use the formula just like I did earlier. Okay. So this is from the formula sheet. Because now if I'm able to solve for n, I can just plug in all that given information into this formula right away, right? And so what I find is that n is the natural log, so ln, of the future value is the 8,056 divided by the present value, which is 4,000, divided by the ln of 1 plus, you can do it inside here, right? I is just r over f, so you can do it here, 0.04 over 12, or you can do it over on the side, right? So I guess I should have found I first, doesn't matter. Like I said, you could do 0.04 over 12, right? or find I equals R over F equals 0.04 over 12 first, then plug it in. It doesn't matter, actually. You're doing the same thing. But because I forgot to find I, I'm just going to do it inside there. So what you want to do is you want to simplify inside the brackets first, and then take the logs or the natural logs if you prefer. So this becomes 8056 divided by 4,000, the natural log of 2.014 over the ln of 0.04 divided by 12 plus 1.0033 repeating. Make sure you keep all those. You can either store it and use it that way, or just as you get more comfortable with your calculator, you can just kind of have it on your screen and take the ln and use it that way. So I'm going to store it. So store it in 1, let's say. You can go from here to the next step. So that's okay, but you need to show me that you've plugged in all the values. And here, this is just in case something went wrong, right? Then you're retaining more marks, right? I'm able to give you, the more I see, the more marks I'm able to give you. So yeah, but I know it's annoying. So it depends on how good you're feeling. So we've got 2.014 on the screen, and then to take the ln of it, you just hit ln divided by recall 1 ln equals, make sure that you get an n equals 210.3867056. Let me just make sure that that's right. Is that what you guys are getting? Divided by okay. So in your calculator, it is what I'm getting. So you have to do 8056 divided by 4,000. And you know what? Maybe I'll store this in 1 here, right? That's my numerator, and I'm going to take the log of it eventually. Then I have to do 0.04 divided by 12 plus 1 equals, and then I have to take the log of that, so I'm going to store that in 2. Now to take the log or the ln, you need to have what you're taking the log of on the screen. So what we're going to do is we're going to do recall 1 ln divided by recall 2 ln equals, and that's how we get to the 210.3867055. Okay. The key here, and what we didn't do in the problem that we just solved, is the key is going to be that we have to round these to a whole value. And so we always round up, regardless of the decimal, we always round up. So regardless of the decimal, we always round up to the nearest whole value. Okay. So what that means is that n must be 211. And that's the answer that I have to put into Moodle, right? This is the number of compounding periods. And number of compounding just like for when we had to solve for r, right? We had to solve for I first. So when we have to find time, we have to solve for n first. And so now we remember that n is the time times the frequency. So 211 is t times f, which was monthly 12, okay? So now 211 divided by 12 gives me a time. Now time is going to be a decimal, right? And I just want you to keep it as a decimal and report it to at least 2 decimal places, right? And so 17.5833 repeating. And I'll just say here, report at least 2 decimal places, right, in Moodle. And so here, this is my second Moodle answer. Okay. Last question. Can do it. We're doing it. Last question is going to be like this one here. The start of this one here. Awesome. Cool. So I'll kind of keep it here. Last question is going to be something we've seen for simple interest, but don't let it throw you that it's a compound interest problem, because all that's changing is the formulas, right? And so the ideas of setting up the timeline and dealing with this question stays the same. So that's why I feel comfortable making you do one of these. Okay. Last question. Here we go. A debt of $2,000 was due but not paid 3 years ago. Okay. It's going to be a little bit of a ridiculous question. Kind of relatively small amounts, but long times. It's okay. It's kind of funny to think about. So maybe not funny. Sort of. A debt of $2,000 was due but not paid 3 years ago. An additional debt of $4,000 will come due in 24 years from now. These debts will be replaced. So now we're saying, oh, actually, scratch that. I missed that first payment. You know what? I've got a different plan in mind. These debts will be replaced by a payment of $2,400 9 years from now and a final payment in 15 years. So the rate of interest is 9.4% compounded daily. And we want to find the total amount due today, right? Making today our focal date, right? So that's what we're going to use to figure out, okay, we want to know the total amount that they would owe today. And then there's a final payment amount that we don't actually know how much it is, right? And a final payment in 15 years. So we're going to have to find that amount. And then eventually, so that amount, it has some value today, but then how much are they actually paying at the 15-year mark from today? So here we go. We got to map this out on our timeline. So we've got a past due. Sometimes I'll use negatives if it's past today, but I should say 3 years ago. And then I've got today. And then the original repayment scheme, I was going to pay 24 years from now. Okay, so that's good. So this is at the 24-year mark. But then I'm going to replace the payments with a payment at the 9-year mark from today and a payment at the 15-year mark from today. Now I'm going to use 2 different colors just to show what's going on, right? There's the original repayment scheme and then there's a new repayment scheme. So here, this is the original. Well, the original, they were supposed to pay $2,000 3 years ago. And then they were also meant to pay $4,000 24 years from now. Okay. Then the new repayment scheme, maybe I'll use, says, okay, forget that. I forgot to pay that 2,000 3 years ago, and how about we figure something else out? So now at the 9-year mark, we're going to pay $2,400 and some final unknown payment amount. We know how to deal with this, right? So some final payment at the 15-year mark. So we want to find the total amount due today, right? Making this our focal date. So all of these payments, right? The pink payments added up today must add up to, they have to be equivalent, right? They have to be equivalent to the blue payments today, right? So let's go ahead and map this out. So 2,000 is worth some amount today. In fact, we'll call it future value 1. Okay. And 4,000 is also worth some amount today, but it's going to be a present value and it's my second calculation. So that's why I'm using 2. The sum of these is going to be the total owing today, which is the first part, right? So this is the total due today, or yeah. So that's the first thing that we want to find. And let's just fill out these arrows really quickly here. N is the time, which is 3 times the frequency compounded daily. Oh man, 365. So F is 365. So N, 3 years, 3 times 365 is 1,000, and I guess I could follow suit with the coloring here, 1,095. And then here, if there's room, I'll do the equation that I'm using, right? But 24 years times 365 days is 8,760. Then so here, right, I've got these, the new payment scheme on the same timeline. Again, I'm trying to keep it as condensed as I can. You're more than welcome to do a separate timeline, right, for the new repayment scheme. But what has to happen is this 2,400 pulled back to today is some present value 3. And then this X, this unknown payment amount, has to be some present value 4. Okay. So the final payment value today, well, that's going to be this present value 4, right? And so here I'll highlight that this is the final payment value today, right? Because that's how much it's worth today. And then the final payment amount is going to be this X, which we'll be able to solve for. Notice that the total due today has to equal PB3 plus PB4. Right? So let's put our n's on here. N in this case is 9 times 365, which is 3,285. And n in this case is 15 times 365, so 5,475. I need I somewhere around here, right? And so I'll jot it down. I equals R over F, which is 0.094 divided by 365. Point zero nine four divided by 365. I get roughly 0.00025754. I will store this in 1. My go-to. All right. Now it's time for the easy part. Now I just do what my timeline tells me to do, right? Find future value 1, find present value 2, find the total due today, find present value 3, find present value 4. So here we go. Future value 1 is PV times 1 plus I to the power of n. Now PV in this case is 2,000 times 1 plus store 1, or recall 1, but I just find it's easier to write store 1, doesn't matter, to the power of 1,095. Recall 1 plus 1 to the power of 1,095 times 2,000, just going straight for it, I get 2,651.461175. which in money is 2651.46. I'm also going to solve future value, it's a present value 2. PV2 is the future value over 1 plus I to the power of n. And I'm sorry, I am going fast because I want to just get it done in this class here. So I apologize. So the future value here was 4,000, right? Make sure you keep those arrows straight. 4,000 over 1 plus store 1 to the power of 8,760. But just make sure that you get the same answers that I do. Or if you don't, let me know, because I might have done it wrong. 8760. We'll know soon enough. 4,000 divided by that puts me at, okay, so that is worth 419.1966264. Remember, it makes sense that it's so small, right? Because it's actually 24 years from now. So you're paying interest for 24 years. That's a long time. So 419.20. So the total due today is future value 1 plus present value 2, which is 2651.46 plus 419.20. $3,070.66. So now, right, we can find, we have a dollar amount for PB3, so I can find PB3, but all I know is PB3 and PB4 should equal the total amount that's due today, otherwise we're doing it wrong, right? So now I can find, so we know that the total due today must also equal PV3 plus PV4. So PV3 is, oh, what was it, 2,400 and then 3,285. 2,400 divided by 1 plus store 1. Nice when it's not changing, right? And then I lost it. 3,285 to the power of 3,285, putting me at 1 plus recall 1 to the power of 3,285. 2,400 divided by that. 1,030.019418, which is 1,031.02. We can solve for PV4. It's x divided by 1 plus store 1 to the power of 5,475, right? 5,475, and 1 plus recall 1 to the power of 5,475. Then remember, it's 1 over that times x. So use the 1 over x button. This is probably the easiest. So I get 0.244187606 times x. And of course, I'm going to store this in 2 or wherever you want. Okay. So what we said is that the total amount due today has to equal this plus this, which means I'll be able to use that to solve for x. So what I have here, trying to keep it all available, 3,070.66 must be PV3 plus PV4. So PV3 is 1,031.02 plus, and I'm just going to write store 2 times x. You can write the numbers if you want, but I'm trying to move quickly here. So then now I have 3070.66 minus, right, I need to subtract 1,031.02 from both sides. So minus 1,031.02. which makes 2,039.64 is store 2 times x. Okay. So let's see here. Solving for x, x equals 2,039.64 divided by store 2. So x divided by store, or sorry, recall 2. Hopefully it did it. It did. 8352.758082. So as a dollar amount, 8,352.76. We can use this to find PV4, right? Because we had to find the final payment value today, right? And that is PV4. And then it wanted to know the final payment amount, which is actually what we just found, right? There's a couple of ways you can find part B here. So sorry, I know I'm keeping you, but so this is the final payment amount. I guess it's not just including X. Final payment amount. And PV4 is the final payment today, which is store 2 times X. So now take that times recall 2, and it should be 2,039.64. And notice, PV4 is 30,070.66 minus PV3. There, hands in the air. Ah, sorry I had to rip through it so fast, but I wanted to talk around all of these so that you had a little bit of something to go off of. Okay. So I'm available if you have any questions, and if you want to meet for office hour or like meet anytime, just let me know. Yeah. Oh, so this store two is what I'm calling this number that's times x. So it's like 0.244, yeah, well, it's right there, I guess. Does that make sense? And then I just called it STO 2 or store 2 in my calculations, cheating a bit. It's okay. All right, so definitely let me know if you have any questions, and then just study these problems and how to go about doing these problems for the test on Thursday. Promise. All right. Let me know if you have any questions. Otherwise, I'll see you on Thursday. You don't need to be here, but I'll be here if you have questions during the test.